Next, let's talk about the exponential distribution, another very powerful distribution, right? If x is exponential, if x is an exponential random variable, then the density function is given by 1 over theta e to the power of minus 1 over theta x for values of x bigger than 0. So that is the density function, PDF of x. In some books, you will find it written as lambda e to the power minus lambda x. So just be a bit aware of which version you're using, yeah? Okay, and the expected value of x is theta, and the variance of x is theta squared. So very important distribution, this exponential distribution. And so 1 over theta e to the power minus 1 over theta x, that's the PDF. The expected value of x, the mean of x is theta, and the variance is just theta squared. The CDF, you can derive this yourself. The CDF is just 1 minus e to the power minus 1 over theta x. Good. So this one, if you don't remember this, you can easily derive it, yeah? Okay, great. Let's do an example. Before that, right, there is an important idea that we talk about when we deal with the exponential distribution, and that's the memoryless property, right? The memoryless property, you'll see that in a few minutes, right? Okay, we are told that x is exponential with mean 100. So we are told that theta is 100. Okay. You're asked to find the probability that x is bigger than 100. So, well, probability x bigger than 100 is what? Is 1 minus probability x less than or equal to 100, right? So you have 1 minus your CDF. So this becomes just, what do you call it? Remember the formula I gave you upstairs? So it just becomes e to the power minus 1 over theta x. Okay, good. So that's what I've used here to find the probability x bigger than 100. Yeah, probability x bigger than 100 is just e to the power minus 1 over theta. Remember, the mean is 100, so theta is 100. So 1 over 100 times 100, you will get your answer, e to the power minus 1 or just 1 over e. Good. Same idea, probability x bigger than 400. So we have e to the power minus 1 over 100 times 400. We have e to the power minus 4. So we've settled that, the first two probabilities. Now you asked to work out a conditional probability, right? X bigger than 400, given that x is bigger than 100. So bigger than 400 and x bigger than 100. Let me say it again, right? X bigger than 400, x bigger than 100. The complement will be, excuse me, what am I saying? X bigger than 400, x bigger than 100. The intersection will just be x bigger than 400. So the numerator, you will use e to the power of minus 4. Okay. And the denominator is just bigger than 100, which is e to the power of minus 1, which will work out to be e to the power of minus 3. Now, I've done all that here. You can go ahead and look at the working slowly and so on. This is your final answer, e to the power of minus 3. So this is the memoryless property defined in many textbooks this way, probability that t bigger than a plus b, given that t bigger than a is equals to probability t bigger than b. Again, this is the memoryless property, right? The forgetfulness of the exponential distribution. The probability that t is bigger than a plus b, given that t is bigger than a, is just probability t bigger than b. Yeah, good. So we can use this idea to solve this question as well. Let's move on, right? we have a conditional expectation coming up. So t is exponential with PDF given to you. You recognize this straight away, right? The 1 over theta e to the power of minus 1 over theta x business. You see it straight away. So t is exponential with this PDF, a half e to the power of minus 1 over 2 times t. We asked to find this conditional expectation. Yeah, what is the expected value of t given that t is bigger than 3? You know how to do this problem already. So let's just breeze through it. Yeah. So remember, this is a conditional expectation. So you'll have a denominator, and that denominator will be probability t bigger than 3. And that's easy to work, because this is the same as 1 minus probability t less than or equals to 3. Use the CDF, right? I've done it here for you. Use the CDF, plug in, you'll get e to the power of minus 3 over 2. Done. What's left? We need your expected value of t, given that t is bigger than 3. So we need a numerator, right? A numerator, how does it? Remember, I told you when you have a conditional expectation, you will have an expectation over a probability. What's the expectation? Good. This is just t though. So it's t f of t. What are the limits? Going from 3 to what? Infinity. There you go. 3 to infinity. And you have your t f of t. Now, this thing here, t f of t, you need to use integration by parts. I trust you can do integration by parts. Let me move the screen up. Okay. You have to use integration by parts. And when you do that, you will get your answer as 5 times e to the power of minus 3 over 2. So this thing is your numerator. And what's the denominator? This thing here. I've done it here for you, and you'll get your final answer, 5. So these are some notes from calculus, right? You can go and look up your formula sheet when you studied calculus those days, and you will see how I work these things. Okay. A quick point, if you want to find, say you want to find the expected value of x, given that x is bigger than 2, okay? You want to find the expected value of x, given that x is bigger than 2. One way we can deal with this, right? Let's say, let x be exponential with mean. That means let's the expected value of x be 10, okay? Okay, let x be exponentially distributed with a mean of 10. So you want to find the expected value of x given that x is bigger than 2. One way you can do it, right, is to do a little bit of manipulation. Now, okay, you already know how to do this, right, without doing any manipulation. Just use the denominator at the bottom is a probability, the numerator is an expectation. You can do the problem, right? Easy. But you can do a little bit of manipulation by writing this thing here as, what do you notice? Expected value of x minus 2 plus 2, given that x is bigger than 2. You can see this is the same as this, okay? Except that this x here, I've made it what? Minus 2 plus 2. And what do I do after this? I take this out. It's a constant, right? I take this out. So I can write it as the expected value of x minus 2 given x bigger than 2 plus, if you want, I can write expected value of 2, but I don't think you want to write that, right? I think that's pointless. Okay, it's a constant. So I took that out. Okay. And so let me erase this. Okay. Good. So now that we have written this out, well, the expected value of x minus 2 given x bigger than 2 is also exponential with the mean of 10, right? We rely on the properties of the exponential distribution. Yeah. If x is exponential with mean 10, right? If x is exponential with mean 10, then x minus 2 given x bigger than 2, okay, x minus 2 given x minus 2 is also exponential with mean 10. So there you go. So this thing here, the mean is 10, okay? And so we have got 10 plus this number here is 2. You will get the answer 12.